The very last thing we did yesterday was we solved equations where there was a log and there was also some constants, like some things that didn't have logs with it. Okay? So we did the first problem and then we didn't do anything else. We did this first problem on the front side and we didn't get to anything on the back. So that's what we're going to work on today. But just as a reminder that in order to solve problems where there's logs and constants, you need to get all the logs on one side and you need to get the constants on the other side. So those two things matter. And then the other thing that you're going to need to know, especially for this and really for everything, is don't forget your log rules, that we can combine multiple logs into one log. That's going to help us out as well. So looking at problem 1. Let's start with problem 1. I have the log base 4 of x to the 5th equals 20. Thoughts? We can rewrite it to exponential form. I'm not going to do that yet because I know how these work and I know what's going to make our lives easier. Before I do that, what's actually going to be better for us is to move this 5 here. Because I can do that. Exponents become coefficients. So this is 5 times the log base 4 of x equals 20. Why is that helpful? I can divide by 5. So then I get the log base 4 of x equals 4. That's a way better looking problem than anything we've had all along. Now is a good time to write it in exponential form. So how do I write that in exponential form? How do I write this in exponential form? Which 4 are you talking about?
The base 4.
Okay, so the base of 4, so it'll be 4 to the 4th. Which 4 are you talking about?
After the equal.
Okay, that's important.
Yeah.
So 4 to the 4th equals x. Well, what is 4 to the 4th? $256. So your answer would be 256. Okay, it's problem 2. The log base 3 of x to the 6th equals 12. What do we do? Okay, so this becomes 6 times the log base 3 of x equals 12. And then what do I do to solve that? Divide by 6. And I get the log base 3 of x equals 2. And then, yes, I rewrite it in exponential form. What would that be in exponential form? Yeah. And what is 3 squared? 9. So your answer is 9 to this problem. And that does work, I promise. Okay, let's look at problem 5. What's different about 5? There's no bases. So what's the base if we don't have a base? Okay, so we can add that in there if we need to. Okay, what else is different about problem 5? Okay, so what do I do if I have 2 logs? Combine them. So what happens if I have the log of x plus the log of 5? When I combine them, what am I going to do with that x and that 5? Yes, because our rules say that if we have addition of 2 logs, we can turn that into the multiplication with 1 log. So it's going to be the log base 10 of 5x equals 2. What's next? Yes, then I can rewrite it as an exponential problem, that 10 squared equals 5x. Once you get to this format where you have the log of something equals a number, then you rewrite an exponential form every time. What is 10 squared? 100. So 100 equals 5x. So what's x? 20. Sweet. Problem 10. It's the same type of problem because I have several logs, but then I have something that doesn't have a log with it. So what should I do first? Yes, I need the logs on the same side. So should I move the minus log 8 or the minus log x? I'd move the minus log x because then like it's all the logs will be on one side and then your 3 will be left on the other side. So how do you move that minus log x? Yes. So I add log x to both sides. And I get, how'd you write that on the left side? Okay, log x minus log 8 equals 3. Okay. I turn my subtraction into division. So really this is the log of x divided by 8 equals 3. Because again, when I have subtraction of two logs, I can turn it into one log by dividing those pieces. Okay, so I've got a log of something equals a number. What do I do? Yes. What's my base in this problem? Yes. So when I go to write this in exponential form, what will it look like? 10 cubed equals
X over 8.
Yeah, x over 8. What is 10 cubed? 1,000. 10 times 10 times 10 is 1,000. Equals x over 8. What do I do? Multiply by 8. I got to get rid of that 8, so I multiply by it. And 8 times 1,000 is? Yes. So there's my answer. Logs are probably one of the few times that you're going to end up with really large answers in math. Normally answers are like less than 20. Not with logs. All right, so problem 15 on the notes. We have the log of 9x plus 1 equals 1 plus the log of x squared. So this problem is set up exactly the same way that our last problem, problem 10, was set up. But the difference is it has a lot more variables in it, and that's why I wanted to go over this one. So if I'm going to solve this problem, what should I do first? Yes. Yes, I need to get all the logs on one side, so I'm going to subtract the log of x squared from both sides. And I end up with the log of 9x plus 1 minus the log of x squared equals 1. I can put in a fraction because it's subtracted here. That means that I can turn this into one log, and that one log will be division. So the log of 9x plus 1 divided by x squared. Okay, so if 10x squared equals 9x plus 1, it's a quadratic. What am I going to have to do to solve this?
Equal to 0.
Equals 0, a quadratic formula or factor?
I think we can factor.
I think we can, but we need to get everything to one side. So I'm going to minus 9x and minus 1 from both sides. All right, so I end up with 10x squared minus 9x minus 1 equals 0. Now, this is not a problem that you can just like poof and factor. You actually need to do some work here. So let's review our product sum charts. What's the product? Okay, and the sum needs to be, so your numbers are negative 10 and 1. So then my problem can be rewritten as 10x squared minus 10x plus 1x minus 1. And the reason that works, check your math here. If I were to combine negative 10x plus 1x, do I get negative 9x? Yeah, this works. It's the same problem. We just wrote it differently. Then what do you do from here? Group. Okay, so I'm going to group these two and these two. What do the first two have in common? 10x. So if I divide by a 10x, then I'm left with, yes. Okay. And then what do the next two have in common? A 1. Positive or negative? Why is it positive? Yes, that sign is positive as well. And then I'm left with x minus 1. Hey, we did it right. This problem still equals 0, by the way. And so then my final factors are 10x plus 1 and x minus 1. And then I need to set each of those equal to 0 to find my answers. So 10x plus 1 equals 0 and x minus 1 equals 0. Start with the second one. What's the answer going to be for the second factor? 1. Okay, easy math. Don't have to think about that one. The other one's going to be negative 1 over 10 once you solve it for x. And then what should you do? Plug them in. All right, problem 1 on the homework. Natural log of x equals negative 3. What's the base of natural log? E. So how do I solve this? Yup, e to the negative third power equals x.
I did not know that. Wait, so the thing can't be negative?
Yes, sorry. E, where's that? Second ln, I think? Look. No. For your answer, if you round it to the nearest hundredth, you get what? Okay, that's your answer. Better or worse than you thought? Okay. All right, problem 3. 2 times the log base x equals 2 times the log of x equals the log of 2 plus the log of 3x minus 4. So is this problem like the first type of problems where everything's a log, or the second type where you have logs and constants? The first. Everything's a log. So what should I do?
Is it unnecessary to move the 2 back to...
It would actually be helpful to move the 2 up to the exponent. So that would give us the log of x squared on the left side. And then, Joe, what were you saying to do on the right side? It wouldn't help me to move them all to the same side, actually. You could combine the logs, and what would you do with those? You multiply them, because this says plus, so I need to multiply my 2 and my 3x minus 4. So I end up with the log... Yeah, that's what you would do, is the log of 6x minus 8. So I have the log of x squared on the left side and the log of 6x minus 8 on the right side. So what happens? I can rewrite it as x squared equals 6x minus 8. When I have all logs in the problem, like everything has a log, I don't need all the logs on one side. I need one log on one side and one log on the other, because once I have those logs there, I can drop the log part of it and just set those pieces equal to each other. Because if the log of x squared equals the log of 6x minus 8, that tells me that x squared has to equal 6x minus 8. What do I do with this? Okay, subtract 6x. Plus 8. So I end up with x squared minus 6x plus 8 equals 0. How does that factor? So I end up with 2 answers of what? Positive 4 and positive 2. And then we plug those back in and see what happens. I think they both work, actually. I don't think either one of them is extraneous. Here's kind of a good way to tell if they're extraneous, is if you plug them back in and it gives you something negative. So like what's 3 times 2? And 6 minus 4 is positive 2. That's important. What's 3 times 4? And 12 minus 4 is 8. They both gave you something positive, didn't they? Then both of them should work. All right, problem 4. So is this one where we have all logs or logs and constants?
All logs.
So that means I need a log on one side, a log on the other side. We're good. So on this left side here, if I need to combine these into one log, what do I do because it says plus?
Log X.
Multiply.
X minus.
So it'd be the log of x squared minus x.
Yes.
You okay with that? Okay, I just went ahead and multiplied them together, and that equals the log of 4x. So since I have log of something equals the log of something, then those somethings have to be equivalent. So we can jump to the conclusion that x squared minus x has to equal 4x. So then I can do math. What math do I do? Okay. So I get x squared minus 5x equals 0. This is not a difference of perfect squares problem for several reasons, mainly being that 5 doesn't factor. Number 2 is that 5 has an x attached to it. So there's a GCF here of what? X. So I get x times x minus 5 equals 0. So I have 2 answers. What's my first answer? X equals 0, and the second one is x equals 5. 0 is going to be extraneous. 5 should work. You need to check it to make sure. The only reason I knew 0 was extraneous was because I just thought about it and I said, okay, if I go back here and I plug in 0, I'm going to have the log of 0. I can't have that. This number here has to be positive. It has to be greater than 0. So if I have the log of 0, I already know I got a problem. Same thing on this side. If I have the log of 4 times 0, that's 0. So like that's not going to work. And then here, if I plug in 0, what's 0 minus 1? Negative 1. I can't take the log of negative 1. So I knew 0 wasn't going to work out. It's going to be extraneous. But I believe 5 works. You should probably check that. Okay. I had a request for problem 5 as well. Yeah, I'll do that one in a minute. So problem 5, I have the log base 3 of x plus 25 minus the log base 3 of x minus 1 equals 3. What kind of problem is this? It's got constants in it. So that means I need one log and a constant. That's it. So how do I combine this into one log? Divide. So this would be the log base 3 of x plus 25 divided by x minus 1 equals 3. Now, again, let's just clarify something. We can't just say, "Ooh, these x's cancel." It doesn't work like that. It doesn't work like that. Okay? So, what can I do now with this problem then?
Put in an exponent.
So, if I rewrote it in exponential form, what would it look like? Yes. Okay, so then we have to do some math. It's not horrible math, but it's really not like easy math either. What is 3 to the third?
27.
Okay, so I get 27 equals x plus 25 over x minus 1. So I need to get rid of that x minus 1 that's in the denominator. How do I do that? Yes. If I multiply both sides by x minus 1, then the x minus 1 and the x minus 1 cancel. Because one time I'm dividing by x minus 1 and then I'm multiplying by x minus 1. And when you divide by something and then multiply by the same thing, they just cancel each other out. And then on the left side, what am I going to do? Distribute. So it'll be 27x, 27 equals x plus 25. Okay, not horrible. Getting better. What's next?
You could subtract x.
Okay, I would subtract x from both sides and I get 26x minus 27 equals 25. What else should I do? Why? What are you trying to do right now?
Solve for x.
Yeah, you're solving for x. You're getting x alone, so we need to get rid of that 27. So we'll add 27 to both sides. And I get 26x equals 52. And then what do I do? And I get x equals, yes. So that's the answer I come up with, is x equals 2. You can't see that, but it says x equals 2. Okay. All right, so problem 15. We have 2 plus the log of m plus 3 plus 3 log m equals 10. What can I do?
Move the 2's and the 3's.
Okay, I could turn the coefficients into exponents. I could do that. What else could I do?
Multiply.
What else could I do?
I don't know.
Could you just
I mean, look what it says. 2 log m plus 3 log m.
add?
That's adding, and that'd be what? No, wait. What would it actually be, though? Like, if I were to add them together?
5 log n.
5 log m.
Why are we doing this? Why are we doing this?
Why not?
I don't know. Why are we though?
Okay,
Why
that's
can we
literally
add
all-
now?
Okay, so let's suppose we didn't. All right, we didn't know what to do. No. Okay, hold on. It's not actually. So if we didn't do that from the beginning, okay, then we move the 2's up to become exponents, right? And the 3. So we get the log of m squared plus the log of m cubed equals 10. And when we add, what do we do? Multiply. So we have the log of m. Okay, now think about this. When I'm multiplying, m squared times m to the third. When I'm multiplying, what do I do with my exponents? I add them. So I still either way end up with the 5.
What were you doing?
I don't know what I was doing.
Yeah, and then that 5 can move back down front. And it's just easier to move that 5 down front because how do you get rid of that 5? You divide by 5. And then you have the log, remember base 10. If you don't have a base, it's base 10 of m equals 2. So you should get 100?
Yeah.
Is that a what?
I don't know what I did. I plugged it in and it doesn't work.